We're going to talk about exponential growth and decay. So after the test yesterday, you were working on geometric sequences. And all geometric sequences is exponential functions. Okay? That's all they are. Okay? There's another type of sequence called arithmetic sequences, and those are just linear functions. You will. Okay? So today we're going to talk about exponential growth and decay. All right? Exponential growth happens when? Anybody ever experienced exponential growth in your life? How many of you have a savings account? Probably most of you, right? If you have a savings account, you experience exponential growth. Okay? It's not much. Okay? But it's still exponential growth. Okay? So the formula for doing exponential growth is here, and as Natalie just asked about the note cards, I'm going to give you one right now. But you're going to want, here is the formula for exponential growth, or the function y equals a, which represents the original amount, times 1 plus r. R is the growth rate, okay, as a decimal, and raised to the power of t. Okay. All right. So the original value of a painting is $9,000. And the value increases by 7% each year. Write an exponential growth function to model the situation, then find the painting's value in 15 years. So we're doing two things. We are going to write a function, then we're going to find the value in 15 years. Two steps to this. Okay? And here's the thing. You will be expected to write the functions, and so you have to make sure you do that correctly. Right? And that's easy. So the first thing you need to do, though, is you need to establish what the values of A and R. Establish both of them. So A in this case is what? Okay, 9,000. We're starting with a painting that had a value of $9,000. Right. And R is the growth rate as a decimal. Okay. So what's 7% as a decimal? 0.07. Okay, don't forget, when we change percents to decimal, we move the decimal point 2 places. All right? 2 places. So R in this case is going to be 0.07. So we have y equals our initial amount, 9,000, times 1 plus 0.07, and that's to the power of t. Now, this is okay, but not what I want, because we can easily add those two numbers to get 1.07 to the power of t. All right, so make sure you combine them. All right. So here's the thing. If it's exponential growth, okay, then this number here, that number there, is going to be greater than 1. All right, if it's exponential growth, that value is greater than 1. So when we were talking about yesterday, then that would actually be our value for R, for an exponential function, okay, or I should say a geometric sequence. So this number has always got to be greater than 1. Okay. So it says now find the value in 15 years. So we just type in our calculator, 9,000 times 1.07 to the 15th power. show the value of the painting is, how many decimal places are we using? And why are we using 2? Why are we using 2? Nope. Why 2 decimal places? All right, because it's money. All right, money is always 2 decimal places. The value of the painting is $24,831.28 in 15 years. All right, or you could say in 15 years the value of the painting is. All right, so your way you word it doesn't matter as long as it's somewhat grammatically correct. All right, and I say somewhat just because I'm not always grammatically correct. All right? Okay. All right. Compound interest. All right, so here's another formula for you to add to that note card then for chapter 11. Right. Compound interest. This is what your bank does for you. What's worse is this is what the credit card companies do to you. All right, when you get a credit card. All right. Those people are in the business of making money. And don't ever let them fool you. A, the final amount. Capital A, not a little a. Okay, there's a difference here. P, the original amount or principal, is equal to 1 or times 1 plus R over N, where R is the interest rate as a decimal, and N is the number of times they calculate interest a year. Now, if you have a credit card, okay, anybody here have a credit card? All right, one person. Okay. If you have a credit card, every month the credit card companies are recalculating your balance and how much interest you owe. Okay. So the value that they use for N would be 12 because they're doing it every month. Okay, and there's 12 months in a year. Okay. Your bank, for your interest on your savings account, only calculates this every 4 months, okay, or 3 months. 3 months. They do it quarterly, so every 3 months they do it. All right. So the value of N in that case is 4. Okay. The problem is really that both of them, I mean, not so bad for the bank, but for the credit card company, is they really do it almost every moment. Right? So they're trying to zap you. Okay, so compound interest. P is what we start with. R is the interest rate as a decimal. N represents how many times we're going to calculate it per year. And T is the number of years. When you get into Algebra C, we'll talk about, and we're going to be doing this in my Algebra C class next week, actually. We're doing what's called compounding interest continuously, and that uses an actual value similar to pi to do that. It's called E. So here we go. Write a compound interest function to model each situation. Find the balance after the given number of years. All right? So we're writing the function again. So we need to establish what are the values of P, R, and N now. So P is our initial value, original amount, starting amount, and in this case that is $1,200. Okay? R is our interest rate as a decimal. Okay. So 2% as a decimal is 0.02. And if they're compounding this quarterly, how many times a year does that mean? 4 times. So n is 4. So we say A equals 1200 times 1 plus 0.02 over 4 raised to the power of 4t. All right. 1200 goes in for P, 0.02 for R, 4 for N in both spots. All right. So now you want to simplify this the best you can. So we're going to take our calculator and we're going to do 1 plus 0.02 divided by 4. Okay. I want you to calculate that value so that it's simplified when you finish writing the function. All right. So I'm going to rewrite this as 1200 times 1.005 raised to the power of 4t. So every month then, okay, you are getting 0.5% of interest. Woohoo! Okay? All right? You should be ecstatic about that. I don't know why, but you should. All right? Then we want to know the balance after 3 years. So A equals 1200 times 1.005 to the power of 4 times 3. Now, you are fortunate, okay? You are working with calculators that just do this for you. They have the math print, pretty print, whatever you want to call it, for the calculator. The calculators we used to use, all right, and some of you freshmen are going to end up using them on PSAT day, unfortunately, sorry, on April 12th. And on that day, if you had a problem like this, you'd have to be very careful with this. You'd want to actually change it to 12 first, okay? So my suggestion for you is when you type this in your calculator that you do 1200 times 1.005 and raise it to the 12th power. Do not raise it to the power of 4 times 3. Okay? It's okay on these calculators, but some of you are going to be using the older calculators for testing, and so if you put 4 times 3 in there, it won't do it right. All right? Because I'm going to show you what will happen. If I change my, instead of going from math print, I change it to classic. This is the old style calculator. Notice when I put raised to the power, it just puts a caret there. Okay? So if I do 4 times 3, right, that is definitely not what you just got, is it? Okay? What do we have? About a third of that, didn't we? Okay. Right. So what happens in the old calculator is it raises it to the 4th power, takes that answer, and multiplies it by 3. Okay? So you would, if you end up with one of those old calculators, so you would need to raise it to the 12th power or put the 4 times 3 in parentheses to get the right answer. Either way. All right, so be careful of that when that time rolls around. All right, that's the nice thing of the updated calculators. Okay, all right. Letter B. We have $15,000 invested at a rate of 4.8% compounded monthly for 2 years. Now, whenever we throw a decimal in there for the interest rate, it seems to throw people for a loop. Right? Don't let that be you. Right? Nothing changes. P, our starting value, 15,000. R, what do we get when we change 4.8% to a decimal? 0.048. All right. We got to move that decimal 2 places to the left. So moves it to the front of the 4 and then a 0 in front of that. All right. And if it's monthly, how many times a year is that? 12. Okay. So A equals 15,000 times 1 plus 0.048 divided by 12 to the power of 12t. Okay. And then simplify that part in the middle here. Okay. Which 48 divided by 12 is 4, so I think that's 1.004 now, right? Okay, so 15,000 times 1.004 to the power of 12t. That's the function model. Then we will stick 2 in there. To find out how much that investment is worth in 2 years. The nice thing is it's worth more than it would be if you just calculated it annually. So what did you get, Sebastian?
16,508.
508?
508.
Okay. All right. So you would need to write, okay? The investment will be worth $16,508.22 in 2 years. Okay? Write out a sentence. Make it happen. Okay? A sentence that tells what your answer means. Okay, last one. No, almost. All right, exponential decay. This is exactly like our exponential growth, except instead of a plus sign, we have a minus sign. Because that number in the parentheses is going to be less than 1. Okay? Exponential decay looks exactly like the exponential growth, except we're subtracting a percent instead of adding a percent. Y is still the same, the final amount. A is the original amount. That's a little a. All right? Make sure you don't mix up your A's. All right? Lowercase and capitals. And R represents the interest rate as a decimal again, or the decay rate, I should say in this case. The decay rate. So the population of a town is decreasing at a rate of 3% per year. In 2000, there were 1,700 people. Write an exponential decay function to model the situation. Then find the population in 2012. Right? Okay, so when you calculate this, you're going to get 1,179.53, right? And the question is, hey, Mr. Carver, this is people. Okay? So you need to show this, okay, that 1,700 times 0.97 to the 12th power equals 1,179.53. But then when you say the population of the town in 2012 is about or approximately or almost or whatever, then you would say 1,180 people. Okay? Then you can round that up to the, or round it to the nearest whole number then. Okay? But show the calculations, show a decimal value there when it's people or something like that, but then when you write it out, we'll write it out in a sentence and you can approximate it and say it's about that number or almost that number. Okay? All right. All right, common application of exponential decay is half-life. Right. And there's formulas here, but we're going to talk about how that works without necessarily using the advanced part of the formula. Okay. Here is the half-life formula. First of all, this you'll need. Okay. We're using P once again for our starting value. And it's half-life, which means that the decay rate in this case is 50%. Okay? So this is an exponential decay problem. It's just that whenever we're talking about half-life, exponential, the rate is always 50%. Okay? All right, how many of you have talked about half-life in your science classes? All right? A couple of us. All right? So all that means is that over a given period of time, the amount of the object, the weight of the substance or whatever, reduces to half of what it was. Right? Now, how many of you have heard of carbon-14 dating? Okay? All right. Probably most of you have, all right, at some point in time, because they've talked about dinosaurs before in your history classes, right? And that there was just recently, in Chelsea, all right, some guy dug up some dinosaur bones in Mastodon, and they tried to figure out how old that thing actually is. Now, there's quite often I don't agree with them, all right, because it's a science, and science, things aren't always perfect in that, right? And they have an approximate, but it doesn't completely work. So here's the thing: it says thing is going to reduce to half its amount in a certain amount of time. So here we have acetone 218. Says it has a half-life of 2 seconds. All right? Okay. It's pretty fast. All right? So if you take medicine, okay, here's the thing. How many of you take cold medicine, or sometimes you take ibuprofen because you have aches and pains? Okay, probably not as much as I do, but all right. So how often can you take that stuff? Okay, if it's ibuprofen, like every 6 hours, they say don't take it. They tell you only do so much in a day. If you're taking cold medicine, depends on the cold medicine, right? Why do they tell you that? They tell you that because it breaks down in your body over a certain amount of time, and it's gone, so you can take some more because it's gone out of your system. Same type of thing, okay? That's why they give you that time frame, because they figured out that's how long it takes for it to last in your body. So, it says find the amount left from a 500 gram sample, and here they changed the wording, it's now astatine, okay, after 10 seconds. Well, so the first question they're asking you is this: how many times are they going to divide it into half? Well, if it takes 2 seconds if the half-life is 2 seconds, and I'm going to go 10 seconds, all right, how many times is it going to cut in half? How many 2 seconds are there in a 10-second period of time? 5 of them, okay? So it's going to happen 5 times. So our exponent here to do this calculation is going to be 5, right? So we would say What is it? We're using A again. Yep. Okay. So A is equal to 500 is our starting value times 0.5, and the number of half-lives that we're going to be working with is 5 half-lives, and that's the value of t you're using, okay? T is the number of half-lives that are going to happen, and they got that by doing 10 seconds divided by 2 seconds is 5, and that's the number that's going to go in my exponent. Or, better yet, you take your calculator, you type in 500, and then you say times 0.5 once, twice, 3 times, 4 times, 5 times. So you don't even need to use a formula. Okay? All right? So they divide it in half once, twice, 3 times, 4 times, and 5 times. So there's now 15.625 grams of astatine in 10 seconds. So you can do this, or you can just type that into your calculator and work it that way. Right? I don't care. Okay? Right? It doesn't matter to me which way you do it. Right? But the whole thing is, when you're using half-lives, that this exponent here represents how many times we cut it in half. Right? So if the half-life is 5 years, and you're going to wait 50 years, then it cut it in half how many times? 10 times. All right? So you'll use 10 for your value of t. Okay.